Hello everybody. Our question is the word search. We have given a board of characters and we have given a word. We have to find that if the word exists in the matrix or grid or not. So, for example, we have this board A B C D E F F C S A D E E and we have given the word A B C C E D. The rule is we can only go to the horizontally neighbor adjacent cell or vertically neighbor adjacent cell. Means if we are at F, then we can go to the B, we can go C, we can go D, we can go S, we cannot go to the A directly, or we cannot go to the C directly. So this is our base case. So we have to return that the world exists or not. We have to return a boolean value. So write the code for it. First we create a variable to store the length of. So we create row and column to store the size of the matrix. After that we will iterate I or j loop to check that this element exists or not. So we have to check that the word first word a match with the our grid element. So we will iterate a loop for I sorry int I equal to 0 to I is less than rows I plus plus and for int j equal to 0 j is less than I plus plus. So we have to check that if the word dot char at index 0 is equal to board dot I and j, that we have to check that this word a is equal to this word a. So we will iterate through this and we have to check that it is equal to, you can see in this example we will iterate from here. We will check a is equal to this, not b is equal to this, not c is equal to this, d equal to this, फिर s we will get s equal to this, then we will go on. We can see we don't find the element, sorry, the word. So we will check next and so on. So we will check our condition that if the word character at 0 equal to the element of the board, and we have to also check up our main function which we will iterate. So first we create this function public boolean search. This take 2D matrix board I j, and we will also include an index for matching the word size. We will include string word that we are searching, and one more thing, we have to add a boolean array which represent that the element is visited or not. The condition is we cannot go to the same cell more than once, so we have to check that the element is visited or not. So we will create a array visited equal to, and after this we initialize our the boolean visited visited array to new boolean rows and column. So initially every value of the visited will be the false, and we will search for the boolean, let me zoom it, boolean array visited. So So first, when we search to the element, we will mark it as visited. So visited I j equal to true. So visited I is equal to true. We pass the value like board I j. We will start from the index 0. We have the word, and we do not need to use visited because it is a global variable. So this, if this we found this value, then we return the true that our element, our word exists in the matrix. Otherwise, we will return false. So we will mark visited to in this array, and we will find at different test cases. We will recursively call different elements. Like if we are at F, we can go to the B, we can go to the S, we can go to the C, we can go to the E. So if we search board I plus 1 J, we will increase the index plus 1, word is same. So there will be the four condition: I plus 1, I minus 1, I j plus 1, I j minus 1. If any of this becomes true, we will return true that our element find at this index. So after this, we will mark. Sorry, we have to move this to the this, and we can format it. And after that, we will mark visited I j equal to false, because we have to reverse the changes for the next word checking. By this, we can multiply users of the visitor node. So after this, we have to add the constraint check, like we do not go to the index more than its column, or minimum we have the row number row index 0, or we cannot go to the column more than its length. So we will check, we will add constraint to it, that if I is less than 0, or I will greater than or equal to board dot length, or j is less than 0, or j is greater than or equal to board 0 dot length, sorry, spelling mistake, 0 dot length, or the main constraint is, we can do this or like this. We, the main constraint is that the word at word dot char at I, caret at index, that we have given index for the each iteration, and we have to find that the index is equals to the next word. So at index of the word, we have to find, like we are at C and we go to the S, so we have to match that the word at this particular index, means the word at this C is equal to S. So if it will equals to S, then we will carry on, otherwise we will return, means it cannot be our the path. And we have to mark visited ij. So if it is false, then we can, so false, then we return false. And the main constraint that if index equal to word dot length means our all words are processed. Our all character in the words are processed. So after this we will return true. So this is our search function. If we have in the search function, we create a bold boolean which will mark that we have particularly checked that index or not. We have row size of the board and column of the board. So we will set new booleans row column size of the columns row columns. We will iterate. We will search each element that it is equal to the first word of the element. So if the first word of the element means first word of the word is equal to the board ij, and we have also searched that this element ij found in the word. So we will check that this element found in the word. So this function if index equal to word or length means all the indexes are processed. So after this we return true. Otherwise we check constraint that for this particular index ij, if I represent the size index and j represent the column index, so size index should always greater than or equal to 0 and less than the length of the board. So I less than 0 and I should always greater than board the length. If j is less than 0, j should always be board the length, and we do not find the character at particular index that is given is not equals to the board.ij, and visited is not equals to false. So after this we will return false. Otherwise we will mark visited true, and we will search board ij different direction in different direction, and after this we return ij false. So after this we check new boolean visited equal to new, sorry, it is 2D array, so we will mark 2D array and we check. So I think there are not any error, there are some typos. So at this index became out of bound. Put I equal to 0, j equal to 0. Sorry, we did I plus plus, we have to do j plus plus. So sorry for the mistake. And this accept our test case. We run our solution. We get a solution of 146 millisecond, which is quite better. 57.37 users are below us. So this is today's problem. Thank you.